This here is my World of Meteorology presentation. I created this for the 8th grade class of Pontiac Junior High School. Now, this is the video portion of the presentation. You will not be able to see the hands-on activities that I did in the class, but this goes through the slideshow, and I'll describe each of these slides here. So what do I do? So I began to study weather in 2004 when I was only 7 years old. So now I'm 18 years old, which means I have been studying weather and how weather works for the past 11 years now. I started off by learning the basic cloud types. In 2009, I became an official storm spotter as a 6th grader. Also in 2009, I began measuring precipitation, reporting it daily. In 2013, I began to partner up with the fire department, the Pontiac Fire Department, on their storm watching team. Then when disaster strikes, I help with the relief efforts, and that began this year. Now here's the day it all began for me. So this is the day that inspired me to begin to study the weather patterns and how they work. And, so I began to study how something like this can happen. So it was May 30th, 2004. I remember this day very well in my memory. It was a huge tornado outbreak that hit Illinois. Not just Illinois, but also a vast area of the Midwest. So if you can see here on the right, this is a Storm Prediction Center severe weather outlook that was issued that morning. The green lines you see here means it is a slight risk of severe storms. That means thunderstorms are possible, and a few of those storms could produce severe weather. Things start to get real interesting here in the pinkish area. You see, that means that is a moderate risk. Moderate risk implies that there's a pretty good chance of seeing a more widespread severe weather event. And then the red area means you're screwed, meaning that there's a major severe weather outbreak is anticipated, usually in the form of widespread tornadoes and damaging winds, stuff like that. So what I remember in my memory is that morning I could see Tornado Watch being scrolling across the bottom of the screen when I was watching TV with my mom. Then I saw this map on the Weather Channel, and it showed half the country or something like that in this orange shading, which means thunderstorms. So it was a very stormy day for a lot of the country. Then in the Midwest region, extending out to the east, there was this red shading, which means that there's the threat of severe weather. And then you see this white color that was right over Illinois and parts of the Midwest, and it said greatest threat. And I hadn't studied weather maps up until that point. So I didn't really know exactly what greatest threat meant, but I knew it wasn't good. So I'm just like, crap, this definitely can't be good. So then I fast forward to that evening, because that's the next thing I remember. I remember my dad saying that we were under a tornado warning, and I had my sister and my 2 step-siblings as well. Were all at the house at the time, including my mom and dad, of course. So they made us get our shoes on. I put my little sandals on. And then my mom poked her head out the door, and she's like, the tornado sirens are going off. So at that point, we all went in the basement. And in my room, me and my brother had 2 beds. They were high-rise beds where you could fit a lot of stuff underneath the frame. So we all kind of crawled underneath the bed frame, and we kind of just sat there as the sirens were going off. You could hear it from... You could hear it all the way outside, and you're in the basement. You could still hear them. And we sat under there. My dad was listening to the scanner, and they were saying over the scanner that this thing was going to head right into town. And so so it's definitely not a good situation. And we all just started freaking out. I started crying. My brother started crying. My sister started. We all basically just started crying. And I do remember. I'm not sure if my parents remember this, but I remember it, that they took all the toys out from underneath the bed for both beds, and they built this wall of toys in between the bed frame and the door, saying that it would shield us from the winds. Now, I have no idea if that would have actually protected us, but I'm pretty sure it wouldn't have. I'm pretty sure they just did that just to make us feel better. If a tornado actually did hit the house, it probably would cause those toys to become airborne, and it would probably be more of a hazard to us than actually shield us from anything. But I do remember the electricity went out just a few minutes later. We could hear the winds just howling outside. But I later found out it was a near miss for the south side of town. There was some damage reported from that tornado. It did not hit the house, but it was a near miss for this part of town. And that was a very scary experience for me, and it scared me so bad that it inspired me to become a weatherman. Well, what happened next? Well, after that event, I started learning the different cloud types. So like back in the first grade, my mom got me this poster that had different pictures of clouds on there. And I never really took a good look at it until after that event. So one afternoon, I went outside and I looked at the poster, and then I would look up at the sky, and I would try to name the different clouds that were above my head at that point. And sometimes I would lay out there all afternoon just trying to name the clouds. I got real good at that after a while. And then, after that very scary experience, I wanted to learn about severe storms and like how they form and stuff like that. So I started going with my mom to the library, and I would check out these in the kids section. They had all these different books about severe weather and stuff like that, and I would check them out. Every time I go there, I have a new weather book in my hand, and I would impress the librarian. The librarian couldn't believe how many weather books I would take from that shelf. And I would read them over and over and over. When I finished reading them all, I would read them again. And then after a while, after reading it for so long, that stuff just kind of stuck, some of those concepts about weather just stuck in my head. I discovered a real cool game online, which for some reason I can't find anymore. Maybe it was taken down, but you can adjust the width of the tornado, and you can adjust how fast the winds are in that tornado, and you press like a go button or something like that, and the tornado goes across the screen and it hits like this farmhouse, and it'll do damage on the house based on how high your winds are set. And so when the tornado passes, then you have to rate the tornado. You have to guess the tornado's rating. So that's on a scale of 0 to 5, 0 being the weakest, 5 being the worst. And I would play that for hours. I would play that so much that my dad one day came up to me and he's like, "A tornado is going to spin up in your head if you keep playing that game." Becoming a storm spotter / chaser. Now, on March 19, 2009, I became an official licensed storm spotter. Now, before I talk about that, the image here on the right you see is a more recent chase of mine. This was in Easton, Pennsylvania. I was pointing in the direction of this ginormous thunderstorm that came through. It was kind of off to my northwest going into New Jersey. I'm pointing at it and taking a look at it, and I was also wearing my Skywarn storm spotter vest right there. So I became an official storm spotter on March 19, 2009. Now you're probably wondering, how in the heck do you become a storm spotter? Well, in order to become an official storm spotter, you have to take a training course. It is held once a year at the Pontiac Fire Department. It's also held at various locations across Illinois. They have a list of like spotter classes that you can look at. And I remember going there, and I think I was with my dad. But everybody there was like, I would say, like their 30s, 40s, and up, stuff like that. And then here's this 12-year-old boy sitting in this chair. I felt really out of place. I'm like, am I really supposed to be here? I was probably the youngest storm spotter out there, at least in the local area. So they taught you a variety of different things, how to safely observe and how to report severe weather. And a good example is like, if you see a tornado or a funnel cloud, if you see one of them, first off, you wanted to determine, is it really a tornado or funnel cloud, or is it a lookalike? Because there is a lot of lookalikes out there. There's a type of cloud called a scud cloud that looks a lot like a funnel. So if you think you see a tornado or a funnel, watch it just for a little bit. And if that thing heads for the ground and it's rotating real fast, if you can see it spinning, then you call 911 and you say, this is a trained storm spotter, because you want to say that, because if you say you're a trained storm spotter, it's going to sound better than, like a random citizen calling saying they think they see a funnel cloud. They like to have trained personnel out there. So you say, this is a trained storm spotter. You give them your location, like what road you're on, what's your nearest intersection. And then you'd be like, I have a tornado to my 11 o'clock, or, wherever the tornado's at. You kind of try to estimate the distance, how far away is that tornado from you. It can be difficult to kind of estimate how far away a tornado on the ground is from your location, but you give an estimate right there. And you give them a direction, like what direction is those clouds going, and then there you go, there's your report. That report is sent to the fire department. They'll dispatch whatever they need. It's also sent to the National Weather Service to give them information as well. These are some of the variety of things that I have reported in my already several years of storm spotting. I've reported tornado touchdowns, funnel clouds. I've reported high winds and wind damage. I've reported hail. Hail is not really too big of a problem, at least in the Pontiac area. We don't see a whole lot of hail, but I've seen hail anywhere from the size of a pea to the size of a golf ball. I did experience some golf ball size hail in a storm chase. Well, it was an unexpected storm chase, I guess you could say. It was a storm chase in Nebraska when I was traveling through, and we had hail up to the size of golf balls in one of the storms we passed through. I've reported flooding. I've reported, like river flooding and flash flooding, and I also report daily precipitation. This right here is my storm chase vehicle. I don't have anything fancy. It's just a black Toyota Corolla. I used to have a truck, and I no longer have that truck because it had some problems and it guzzled a lot of gas. So this is what I used to chase. Nothing too special. You'll have to ignore that reflection that's kind of towards the front of the car. On top of the car is a strobe light that sometimes I use. You'll have to check the description in this video to find the video I put together of some of my best moments during severe weather and storm chasing. So I've had cameras and I've had a YouTube channel since 2007. And so I've been recording storms ever since then, and I have this enormous collection on my YouTube channel of various storms and like snowfall, stuff like that I've filmed over the years. So you'll definitely check that out. So you just go in the video description and click on it. Click on that link and it'll bring you to the video. This background image you see is an image I took on June 5th, 2010. This is an enormous tornado. It was a very large tornado. It was a wedge. This wedge tornado that was crossing the road in front of us. It was at least a handful of miles away though, but it was very large, crossing Interstate 55, Route 66, and then just to the right of there is the little village of Dwight. So this is the tornado that kind of touched down by Streeter, and then it cut into the south side of Dwight and wiped out all those mobile homes. Now I'll talk to you about the COCORAHS network. COCORAHS stands for Community Collaborative Rain, Hail, and Snow Network. It's a big long acronym. I joined this in October of 2009. So to this, I report precipitation amounts to this program every day. Well, I try to every day. You're supposed to report zeros on the days you don't get precipitation, but sometimes I kind of slack when things get dry. But you're supposed to report any precipitation you see over a 24-hour period to this network every day. My reports can be very useful There's my reports can be used to predict like how high the river is going to get. Like if a river is coming up, like the Vermilion River is coming up, and it could potentially at flood stage, they want to know like exactly how high it'll be, and they can use my reports to make that prediction. I also help out with disaster relief. So when originally when I started storm spotting and chasing, it was kind of more, all just for the sport of it. But, and then kind of got thinking like natural disasters such as tornadoes, hurricanes, tsunamis, volcanic eruptions, all different kinds of disasters can happen, and they can be very devastating to communities. They wipe out buildings, they kill people, they displace people. And so I kind of wanted to help out, when disaster strikes. So in April 2015, I partnered up with Samaritan's Purse, which this is kind of like a church, somewhat like a church, except, you don't go into a building on a Sunday and go to a church service, but instead this ministry reaches out to people by responding to disasters that not only just here in the United States, but internationally, such as the Nepal earthquake. We got Samaritan's Purse volunteers right now that is helping out with the Nepal earthquake. So I responded to the tornado that hit Rochelle, Illinois on April 9th, 2015. It was a tornado that cut through the northern part of Rochelle, Hillcrest, then it hit that little village of Fairdale, and then it dissipated kind of by Kirkland. It was rated a very high NDF4. It was almost a 5. Didn't quite make it. So a couple weeks later, it was me and my friend Chloe went up there, and we arrived at this church. It's called Crossroads Community Church, and that's where the Samaritan's Purse was kind of using as their base station, where they keep all their volunteers that are staying overnight. We did not do an overnight stay. We just helped out for the day. And so we went in this big convoy. Oh, no. First thing off, we took the safety course that kind of, so we can know, like, what to pick up, what not to pick up, stuff to avoid, stuff like that. So after that course was done, we all gathered in this big circle, and we joined hands, and we prayed for the day to go well, for the volunteers to learn something, and for us to make a difference in the name of God. And so we all got in this big convoy of cars, and we went out to this rural area outside of Kirkland, Illinois, and we spent the day picking up debris that was in this farmer's field. And we found all kinds of stuff like glass and pieces of building, trees, all kinds of debris that has been thrown around, and it was stuck in the ground. And farmers can't get in the field whenever there's tornado debris or any debris of that sort stuck in their fields. So we spent the day just picking that stuff up. It was a lot of fun, and it was so awesome seeing all these people come together to make a difference like that. And that was my first ever disaster relief effort, and I'm definitely hoping I can do it again soon. We also, after that, we had some time left that evening, and we took some pictures around the Rochelle area, which is not included in this PowerPoint presentation, but we saw houses just completely swept off their foundations and barns just destroyed. It was a horrible sight to see. This is another picture from that day. As you can see, this is all the Samaritan's Purse volunteers that responded that day. There's two guys over there that are kind of standing by that white truck. They're, I guess what you'd say, the pastors that came and spoke with us for a while. He talked to us about like what we did that day, what it meant to people, and how we can continue to help alongside Samaritan's Purse and spread the word of God through disaster relief. it was a great experience. If you ever want to do something like that, definitely get yourself involved in something like this, because it's worth every minute you're up there. Now for some edumacation. So some of the things I talked about to the 8th grade class, not only did I discuss, what I do as a storm chaser and showed them all my equipment, but I also described some of the basic weather patterns that influence the daily weather across the United States. So a wide variety of weather systems can affect us. And so some of the things that will be talked about would be high pressures and low pressures, cold fronts, warm fronts, and stationary fronts. Starting off with high pressure systems. These are also called ridges or anticyclones. Clear to fair weather will accompany high pressure systems that pass through. They're formed by the downward pushing air. Now, you guys have known since elementary school that warm air rises, cold air sinks. So this is cooler, dense air is sinking towards the ground. This is what forms the high pressure systems. Strong high pressure systems can cause heat waves and cold snaps in the summer and winter. And this is because, especially in the summertime, high pressures clear the skies out, and you get these suns, and the high summer sun is beating down, heating up the ground. The high pressure is trapping all that heat towards the ground, and so that causes your temperatures to rise. And if that high pressure is very large or doesn't move very fast, it causes that heat to build up until it's relieved by a cold front. Similar concept in the wintertime. High pressures pull in a bunch of Canadian Arctic air, and it traps it towards the ground, and that's what causes your bitterly cold wind chills. This is a map from the National Weather Service from Friday, August 14, 2015. As you can, this is a very stormy time across the country. But the only high pressure you see on this map is over here on the East Coast. So while everyone else was getting rained on, the East Coast was sucking up all the glory and getting all the sunshine and the dry weather. Low pressure systems is what we talked about next. These are called troughs or cyclones. Obviously, they are the opposite of a high pressure, formed by the rising of warm, less dense air, forming these troughs. Low pressure systems bring all kinds of stormy weather to the area that they pass through. So you can see anything from a cloudy day to a crazy tornado in your backyard or a big flood. Any type of unsettled weather is going to be coming from some sort of low pressure. This is that same map we just looked at. Now, this one's going to be obvious to point out, but the low pressures are the big red L's you see all over the map. Now, we'll talk about warm fronts. Warm fronts are designed as the transition zone where warm air replaces cold air. Warm fronts are almost always going to be moving in a north or northeast direction. You don't see them moving in any other direction very often. The air behind a warm front is much more moist than in front. So when a warm front is coming through, that moist air kind of moves over the cooler air, and that condenses clouds and eventually will cause widespread rain. So if you've ever experienced where it rains all day non-stop and then it continues in the next day, usually it's the result of a slow-moving warm front. Warm fronts can also produce thunderstorms as well. Whenever the ground is nice and cool and you get a warm front passing over the cool ground, it can cause fog. So sometimes you wake up in the morning and it's real foggy. It's because there's a warm front passing through. Ice storms have been known to be triggered by passing warm fronts, especially when there's a blocking high pressure to the east, because the high pressure tends to trap that colder air towards the ground. The warm air is your source, or the warm front is your source of warm air. So it causes the snow that's falling to melt into rain, but then it freezes on the contact where the cold air is only at the surface. The 8th grade class is challenged to find the warm front on this map. There's technically only one major warm front on this map, and it was right here, kind of up there into southern Canada into the far northeastern Minnesota region, in between these two low pressures. Cold fronts. These are probably more common. You probably have heard about it a little bit more than warm fronts because they are more common. This is the opposite of a warm front, obviously. So this is where cold air replaces warm air. It's that transition zone. Cold fronts can come in all different directions. In our area, it's most common it's usually moving from west to east or northwest to southeast. These fronts are located in the wake zone of a low pressure system. So this is the zone where low pressures wrap this cold, dry air around its backside, and then it creates those fronts just by that conveyor belt type system. Cold fronts move faster than warm fronts because colder air is heavier and more dense, so it obviously will replace warm air faster than what warm air would replace cold air. Cold fronts are often the trigger of severe thunderstorms in the spring and summer. Now this happens because, say you get a warm front come through, it provides your warm, humid air. And then this cold front comes through, and because cold air is sinking, it's going to replace that warm air. So that warm air has to go somewhere, and because warm air is less dense than cold air, it rises. So that warm air will rise and it will condense to form those storm clouds, which can cause severe weather. If you've ever had those days where it's like 90 degrees and then like in an hour it drops to like 60, this is usually, well, no, I should say this is always the result of a passing cold front. This is a good example of a cold front inside of a cyclone that I found on the internet. So you have your warm front here on this end of the low pressure. This is where all your warm air is being infected this direction. Then your cold front forms right here. This is where this cold air is just wrapped around its backside. And that zone, that transition zone where the cold dry air replaces that warm moist air, is where that front is located. This purple you see right here is called an occluded front, and that's where cold front overtakes a warm front. Stationary fronts, this is where cold and warm air equal out each other, so they don't replace one another. These fronts do not move at all, and sometimes they don't move for several days. Storm systems are able to kind of rotate off, say from like the Midwest region. They'll like spin off from the Midwest, and then they'll travel along these stationary front boundaries. And so when they train over the same area, it can cause a lot of flooding in the summer, and also major ice storms or snowstorms in the winter. What is wind? Wind is defined as the large-scale movement of gases on Earth. Wind is caused by differences in high and low pressure. So obviously the replacing of air masses, like we just talked about, this is what causes the wind. Air moves from the area of high pressure to the area of low pressure, just like osmosis. You have your high-density particles are in one area, and they're going to tend to move in an area, whereas low pressure. You can also, a good analogy of that is like you're caught in a big crowd in New York City, and there's this big cluster of people, and you kind of want to break free of that crowd, and you want to get off on your own so you're not so confined. The tighter the pressure gradient is, the faster the winds are. Speaking of pressure gradients, here's a map of a particularly intense cyclone that moved across the Midwest on November 17, 2013. If you look over here on the western part of the United States, the isobars here are very They're more spread out for the most part. But you come over here, and this crazy storm that's blasting across the Midwest and the East, you can see how these lines, these bars, are really close together because of this intense cyclone that was moving across northern Illinois. So in this region here where the bars are real tight together, this is where the highest winds are. Some locations experienced wind gusts over 60 miles per hour that day, not counting the winds you got from thunderstorms. Speaking of November 17, 2013, I'm going to talk to you a little bit about that. Now, this day is a classic example of why you never want to let your guard down because severe weather can strike at any time of the year. It does not have to be in the peak of severe weather season. It can happen at any time. And this particular one was, like, I believe, the 4th worst tornado outbreak in Illinois history, and definitely the worst for November. As we saw in the previous map, it was the result of an unusually strong cyclone in the fall, which provided the conditions for this event. This is also the day of the Washington tornado. Towards the beginning of this presentation, I talked to you about a high risk, and that if you go under a high risk, you're screwed. Well, we were quite literally screwed that day. So this is an outlook that was issued, what time was that? It was issued that morning, looks like about 8 o'clock that morning. Big slight risk was issued all the way to the eastern seaboard, big moderate risk, and then in our area, we were under a high risk. So they issued a high risk, and that's their highest level they can go, which means that a major outbreak of severe weather was about to occur. And indeed, that was very major. I found this excellent image from AccuWeather online of the conditions that came together to form such a nasty tornado outbreak. So what we had here was this jet stream. This really strong jet stream came through. And this jet stream provided the steering mechanism for this really intense storm that was up here in the upper Midwest region. So this jet stream not only steered it, but it also prevented this low pressure from going south. So this means we were south of the low pressure. So when you're south of a low pressure, that means you're in the warm sector. So that allows warm and humid air to come up from the Gulf of Mexico and sit over the area. At the same time, because this thing was so darn intense, it started drawing all this cold air from Canada. And so it formed this really intense cold front that was kind of draped across the Midwest, and it was a very quick mover. It moved really fast to the east, and when it started interacting with that warm, humid air coming up from the Gulf of Mexico, storms began to erupt all across the area. So this main impact area is where this severe weather event unfolded. This is the storm reports of that day. 136 tornadoes were reported to have touched down on that day. Tornadoes touched down in Illinois, Kentucky, Tennessee, Indiana, Michigan, and Ohio. Looks like most of the tornadoes were located in eastern and central Indiana. I surely wouldn't have been in that cluster of tornadoes right there that you can see, that little cluster of red there in eastern Indiana. The Pontiac area is located approximately right here, if you can see my cursor. And so we came pretty darn close to some of those tornadoes. Also, there was 42 reports of hail, which are indicated by the green dots on the map, and there was 579 reports of damaging winds. So that amounts to 757 total reports on that day. Absolutely insane. So when a cold front is moving off to the east, or moving in any direction, it pushes its energy, pushes all the active weather with it. So as this cold front came through our area that afternoon, the severe weather event began to shift into Indiana, Ohio, and that region. And so storms diminished behind the front. And what amazes me is this thing was so strong that you go just you go a few states to your northwest, there's so much cold air being wrapped in behind this low pressure that it started snowing in Minnesota and the Dakotas. It's amazing how all this weather can happen in just one system like that. Here's an animation of that day. So there's your warm front that comes through. It lifts northward. And then there comes your really strong cold front and blasted through, just like that. And so severe weather would have formed along and ahead of that cold front. Supercell thunderstorms are considered the most dangerous type of thunderstorms that develop. The Midwestern United States frequently experiences these storms during the spring and summertime. They have been known to produce violent tornadoes as well as very large hail and winds over hurricane force. Tornadoes. A tornado is a violent, rapidly spinning column of air. Usually are developing for supercell thunderstorms, but they can touch down from any kind of storm. The most intense tornadoes have had winds over 300 miles per hour. Tornadoes can be very narrow, as narrow as like 10 feet across or as wide as 2.5 miles. I'm pretty sure the El Reno tornado of 2013, it was over 2 miles wide, and it ended up being the widest tornado in recorded history. Most common question I am asked as a weather enthusiast, future weatherman, is how do they form? So you get a phenomenon called wind shear, which is wind blowing at different altitudes and blowing at different speeds, so blowing in different directions. So that's your wind shear. It sets air spinning off like a barrel, like a horizontal barrel. And then you get an updraft or some sort of lifting mechanism, usually from a cold front or something like that. It tilts these things vertically. And so if the conditions are right, if conditions are right, then that vortex can narrow itself down, especially as the rain and the winds start to come down from the storm. It'll pull that funnel with it, and then it's officially called a tornado once it touches the ground. How do you know one's coming? Well, if you spot one on the ground, then you obviously know one's coming. Or Doppler radar can also show you rotation. This is an example of radar-indicated rotation. This was the Moore, Oklahoma, Bridge Creek, Newcastle tornado of May 3rd, 1999. As you can see, there's the supercell thunderstorm. But then here on the southwestern part of the storm, where it's kind of hooking around like that, there's where your tornado is. This is where the mesocyclone, this is where all the rotation is, and the tornado is located right over Bridge Creek at this point in time. Another example of radar indicating rotation. This was the Moore tornado on May of 2013. So yeah, Moore, Oklahoma had 2 massive tornadoes that hit. So this is the 2013 tornado. You can see the same hooking feature on this supercell over here, and then right here is the velocities of the storm, and where this green and red meet right there is where the mesocyclone is, and that's where the tornado was located. So that's how you can kind of see where that's how you know Doppler radar had. This is how you get your tornado warnings even before tornadoes are spotted. So when Doppler radar shows signatures like this, you know a tornado's headed your way. Tornado warnings. These are issued by the National Weather Service. Means a tornado has been spotted or is indicated by Doppler radar. Tornado warnings usually last less than 45 minutes and take cover immediately when one is issued. And do not rely strictly on tornado sirens to give you the warning, because for one, tornado sirens are meant for outdoor warning, so you may not hear it inside unless you're really close to a tornado siren. Sometimes those sirens don't go off either, so you want to have like a weather radio or something like that to be able to receive warning so you can get to safety. This concludes this presentation. I thank you guys for watching. I'd like to thank the Pontiac Junior High School for letting me come in and do this presentation. So yeah, thank you for watching this.